All right, good afternoon to all of you. This is a sample problem being used to develop the concept of relative motion. So you have, the concept development for, let's talk about concept development, for relative motion. Okay. So that's a topic, and we will use a situation to help you understand this. So you have a car which is moving towards right, and the right is considered to be eastward with 5 meter per second. Okay, and this is a velocity of the car, and you have a stationary observer, watching the car move. So here is your, the situation, and you have an observer, okay, watching this car go towards the eastward direction, and this gentleman, sees the car going on the right hand side. So I'm showing this velocity vector towards the right, and then there is one more car, which is coming towards left side, which is with a velocity of 10 meter per second, right? And this is, so if you talk about this observer, when he looks at the car number one, he sees the car number one going rightwards, and when he sees the car number two, he sees that car moving leftwards. Now, if this observer, instead of being a stationary, observer, which means the velocity is 0, okay, of this observer also starts moving in some direction. And for simplicity and development of the concept, let's say that this observer, starts moving in the right hand side, and he moves with a velocity of maybe 3 meter per second. Okay. Now question is, what is the relative velocity of car 1? What is the relative velocity of car 1 with respect to the moving observer? Okay, now the observer is in motion. So that's the way we write it. Car 1 with observer in motion. Okay. Now we know the velocity of car as seen by the stationary observer is written by this velocity magnitude. Let's put it as V1, which was seen by the stationary observer. So this is the velocity of the car with respect to stationary observer, right? See the subscript stationary and then we have to subtract the velocity of the observer, and therefore we just write it as minus velocity of the observer. Okay. So if you were to represent the concept on a graph, the velocity of car is towards the right, 5 meter per second, but the observer is moving on the right hand side, right? So the observer is now seeing the car, but observer has some velocity 3 meter per second. That velocity gets subtracted, right? These are anti-parallel vectors having an angle of 180 degree between them. So this observer velocity becomes minus 3 meter per second. And therefore, when you write the resultant, which means the velocity of car as seen by the moving observer, would be written as, is equal to 5, and you can, because they're along x-axis, minus 3 is equal to 2 meter per second. So this observer, who's moving with velocity 3 meter per second, sees this car moving with a velocity of 2 meter per second. Now let's talk about what happens to the motion of the car 2 as seen by the observer. Again, the velocity of this car V2, is leftward, and therefore you would associate a minus 10 meter per second sign because it is leftward. Okay, all the velocities which are leftwards, in a coordinate system are negative velocities, and the velocity of the observer is plus 3 meter per second because it is on the right hand side. Your job is to find the velocity of the car 2, second car, let's put it as car 2, with respect to the moving observer, okay, with respect to moving observer. So your car 2 velocity as seen by the stationary observer minus the velocity of the moving observer. And the velocity of the car is minus 10 as seen by the stationary observer. So you write it as minus 10. And then you subtract the velocity of the observer. That means you reverse the sign of velocity of the moving observer. So this is your moving observer. So this is minus 3 is equal to minus 13 meter per second, which means the car number 2 as seen by the moving observer is now moving leftward with a speed of 13 meter per second. So hopefully, it would have given you a sense of relative motion, that the velocity of the observer, gets subtracted from the body under observation. So the body under observations were car number 1 and the car number 2. And initially the observer was stationary, but now the observer is moving, and therefore the observer sees the velocity of car 1 as 2 meter per second and the velocity of car 2 leftward, and the magnitude is 13 meter per second. So take care of the signs when you do relative motion and ensure that the velocity of the observer is reversed, and then the resultant is found out using vectors. Thank you very much. I hope you enjoyed the video and understood it.